Now, how do wind chests work? How does the air actually make the pipe sound and stop sounding? Because you can't have all the pipes sounding all at once, or you just have a mishmash of sound. My organ is an electro-pneumatic organ. There are two different types of chests that work with electric power in my organ. There are what is known as direct action wind chests. This is the framework of the wind chest. It's a wooden box. The top is drilled with many holes that the pipes sit on. Now above this is a rack that keeps all the pipes straight. I didn't draw that just to simplify the drawing. The direct action magnets basically look like I've drawn here, and this is what they look like in real life. Basically, this is a felt pad with a leather top on it that seals against the bottom of the board right here where this port is. It actually sets in here just like this. So this seals against the bottom of the pipe, preventing any air out. This whole box would be charged up with air from the blower at 5 inches of pressure, and this is this right here, stopping off the air so no air can get in. Now when you press the key on the organ, it would put DC power to this solenoid, which will pull this down. Basically, like, if I can hold on to it here, it would basically pull this down like this. And as that pulls this down, it would pull it away from the board and allow air to go out this port and sound the pipe. That's how the direct action wind chests work. Most of the wind chests in my organ are electro-pneumatic wind chests. They have a small diaphragm right here with the same basic type of felt with a leather top that seals off against the pipe. There's a fairly light spring under there that pushes this up against the bottom of the pipe and keeps it from sounding, because there's air pressure in here trying to get out and sound that pipe. Now the magnet, the organ magnet, is on the bottom, which looks like this. And I'll disassemble this in a moment and show you the internal workings of this. But this is called an organ magnet. Basically the way it works is, as I said, this is charged with organ air all around the diaphragm here and the organ magnet. Gravity and pressure hold the steel disc, which is lined with either felt or leather, down against this exit port. So when this is down, you have 5 inches of pressure comes through this port and up through this port and is inside this side of the diaphragm. So you have 5 inches on this side and 5 inches on this side. So the diaphragm is in neutral air. It cannot move. The spring pushes it up and keeps it sealed, since there's 5 inches here and 5 inches here on both sides of this diaphragm, the equal pressure. Now when you play the key on the organ, it puts DC voltage on these wires, which this is basically a horseshoe magnet. That's this purplish colored part or brownish colored part here. This is a big electromagnet. It's basically just a bent rod that goes inside here. Now when you put electric to this and this becomes a magnet, it's going to lift this steel disc off from this vent port. It's going to lift the steel disc up and close the inlet air and vent the air from here to atmosphere out to the room. The 5 inches of pressure is going to come out and go through the disc, under the disc, and through this port out. So now what you have is an imbalance. You have atmospheric pressure out here, which is 0 inches of pressure, for sake of argument, and you have 5 inches of pressure in this cavity. So what that's going to do is that's going to push on this diaphragm and push this diaphragm down against the spring, which opens this port up and allows this pipe to sound. You would think that this would take a relatively long amount of time for all this to happen, but it happens in a fraction of a second. It's very fast. Probably not quite as fast as the direct action, which I showed you earlier, because that's just the magnet immediately acting on the stopper. But it's very fast. I was actually quite impressed of how fast the action is. Okay, so now we're going to take this organ magnet apart. They all basically function the same, but some of them are designed a little bit different. Some of the Wurlitzer ones have a shaft that sticks up, like a tube that's threaded with a cap on it to get into the disc, but they're basically all the same. On the bottom, this is the port that is in communication with the diaphragm, and there's a port between these rods that's in communication with organ pressure in the chamber. And this hole where the diaphragm is, you can see it inside there maybe, hopefully you can see it, is the vent port. So when you open this up, there's a gasket on the bottom of the door, and this is the actual steel diaphragm. Now the leather, or cork, or I think it's leather, is completely gone from the bottom side, but it is still on that side. So basically, when the electromagnet kicks on, it pulls this up tight and seals the air from coming in here and vents this to outside. And when it's off, gravity, see this is upside down, this would actually be mounted this way in the wind chest. When it's off, gravity lets that drop down where it seals on this port and keeps the pressure the same on both sides. So hopefully you can understand the basics of how wind chests and blowers and regulators and all this stuff works together. On the next section I'll probably cover the different ways that the switches and everything work to operate the different parts. So thanks for watching, and I hope you'll tune into the next section.